During the height of the Cold War, the world witnessed an unprecedented race for technological dominance, and nowhere was that competition more secretive or fascinating than in the realm of stealth aircraft development. The existence of many of these experimental planes was denied for decades, hidden under layers of classified programs, black budgets, and restricted airspace. Only recently have details begun to emerge about the unseen prototypes that shaped modern stealth aviation. These aircraft were the stepping stones that led to the stealth technology we recognize today, such as the F-117 Nighthawk, B-2 Spirit. The story of stealth begins with the fundamental principle of radar cross-section reduction. Radar systems work by bouncing electromagnetic waves off an object and detecting the reflected signal. The stronger the return, the more visible the object appears to the radar. To counter this, engineers during the Cold War began to explore ways to design aircraft that could absorb, scatter, or redirect radar waves in a way that minimized their signature. This led to shapes and surfaces unlike anything the aviation world had seen before. Flat, faceted designs, strange angles, and radar-absorbing materials that seemed more like science fiction than reality. But long before the public ever saw a stealth fighter, numerous prototypes and testbeds paved the way in the shadows of military secrecy. One of the earliest and most important of these was the Lockheed Have Blue, a small, diamond-shaped prototype developed in the 1970s under the legendary Skunk Works program. Have Blue was the first practical demonstration of radar-evading design principles. It wasn't meant to be a combat aircraft, but rather a proof of concept for stealth technology. Its distinctive faceted surfaces reflected radar waves away from the source instead of back toward it, drastically reducing its radar cross-section. Engineers had to overcome countless aerodynamic challenges because those sharp angles that made the aircraft stealthy also made it difficult to fly. They relied heavily on computer-assisted flight control systems to stabilize it. Have Blue's tests proved that stealth was not only theoretically possible, but achievable, and it directly led to the development of the F-117 Nighthawk, the world's first operational stealth fighter. While Lockheed's Have Blue and F-117 programs were unfolding, Northrop was also deeply involved in stealth research through its Tacit Blue project. Tacit Blue looked nothing like any aircraft before it, with a bulbous fuselage, curved edges, and almost no sharp angles. This unconventional appearance earned it the nickname the Whale. The goal was to test low observability with a different design philosophy, one emphasizing smooth, blended surfaces rather than flat facets. Tacit Blue incorporated side-looking radar systems designed to track targets while keeping the aircraft itself hidden from detection. It used advanced composites and radar-absorbent materials that were groundbreaking for their time, though it never entered production. Tacit Blue demonstrated that curved stealth designs could work and directly influenced the creation of the B-2 Spirit stealth bomber. Another fascinating entry in the world of declassified stealth aircraft is the McDonnell Douglas Quiet Attack Aircraft, also known as the Project Quartz concept. This project explored how sound suppression could be combined with radar stealth to make aircraft not only invisible to radar, but also acoustically stealthy. Engineers worked on engine designs that minimized heat signatures and muffled noise emissions, vital for low-level penetration missions. While the project never went beyond the conceptual stage, the research it produced contributed to future developments in exhaust shaping and infrared signature. Reduction that are standard in today: stealth aircraft. The Boeing Bird of Prey, though developed later, in the 1990s, was a direct descendant of the stealth research lineage born in the Cold War. Boeing used the Bird of Prey as a technology demonstrator to explore advanced manufacturing techniques and stealth shaping. Its alien-like appearance, with a smooth, blended fuselage and forward-swept wings, looked straight out of a sci-fi movie. What made it particularly unique was that it wasn't designed for combat or mass production, but as a low-cost test platform to validate new stealth technologies, including the use of composite materials and precise manufacturing processes that reduced radar reflectivity. Much of the stealth shaping data derived from Bird of Prey found its way into future designs, including the X-45 unmanned combat aerial vehicle and other classified programs. Beyond the American efforts, other nations were also venturing into stealth experimentation, often in response to U.S. advancements. The Soviet Union, for instance, was not far behind. Soviet engineers were aware that radar stealth was becoming a critical advantage in air warfare, and they began working on several projects to explore low observable technologies. One such project was the Mikoyan MiG-37, a rumored stealth fighter concept that appeared in Western media after the F-117's public unveiling. Although much of what was written about the MiG-37 was speculation, documents later revealed that the Soviets were indeed testing radar-absorbing coatings and stealthier airframe designs in projects like the Mikoyan Project 1.44 and the Sukhoi T-4MS. These aircraft combined traditional Soviet aerodynamics with elements aimed at reducing radar visibility, such as blended wings, internal weapon bays, and radar deflecting surface treatments. While the Soviet designs never reached operational stealth capability during the Cold War, they set the foundation for later aircraft like the Su-57. One of the lesser-known yet crucial programs was the D-21 drone, developed by Lockheed in the 1960s. Though not stealth in the modern sense, the D-21's high-speed reconnaissance missions over hostile territory relied on radar evasion through extreme altitude and speed. The experience gained from the D-21's Constructionite's titanium airframe, heat management systems, and radar-absorbing coatings provided valuable insight for future stealth technologies. The D-21 was launched from modified A-12 and B-52 aircraft, reaching speeds above Mach 3, making it one of the fastest aircraft ever built. While its missions were fraught with difficulty and secrecy, the D-21's legacy lies in its pioneering approach to unmanned stealth reconnaissance, a precursor to modern UAV. One of the biggest challenges engineers faced during the development of these stealth aircraft was balancing radar invisibility with aerodynamic performance. Traditional aircraft designs relied on smooth aerodynamic curves to reduce drag and enhance lift. Stealth shapes, however, required flat surfaces and angles that directed radar waves away from the source, creating aerodynamic instability. To solve this, engineers implemented advanced fly-by-wire systems that used computers to make constant minute corrections to keep the aircraft stable. Without these systems, aircraft like Hev Blue or the F-117 would have been almost impossible to control manually. These digital flight control systems became the backbone of modern aircraft, not just stealth ones, showing how stealth research benefited aviation as a whole. Another critical component of stealth technology was the development of radar-absorbent materials, often referred to as RAM. These specialized coatings were designed to absorb radar waves instead of reflecting them. During the Cold War, teams experimented with various chemical compositions, from iron ball paints to carbon-based composites. The materials were often extremely sensitive and difficult to maintain, requiring regular reapplication and repairs. Despite these challenges, the breakthroughs achieved in radar absorption became one of the cornerstones of stealth success. The careful combination of material science, airframe design, and electronic countermeasures created aircraft that could evade detection long enough to complete missions deep inside enemy territory. As the technology matured, engineers began focusing on thermal and acoustic stealth as well. Jet engines produce intense heat that can be detected by infrared sensors. So stealth designers worked on ways to cool exhaust gases and mask heat signatures. The F-117, for instance, used shielded exhaust ports that mixed cooler air with hot jet exhaust before releasing it, reducing the aircraft's infrared signature. Some prototypes even experimented with special coatings that dissipated heat across the surface of the aircraft to prevent concentrated hotspots. Similarly, reducing acoustic signatures became crucial for missions requiring low-altitude flight. Engineers reshaped engine inlets, added baffles, and used new fan designs to minimize the telltale roar of a jet engine, especially at low speeds. Beyond the technical aspects, what truly made these Cold War stealth aircraft remarkable was the culture of secrecy surrounding them. The programs operated under intense classification levels, often unknown even to members of the military. Engineers and pilots worked in isolated desert facilities, most famously at Groom Lake, Nevada, better known as Area 51. Workers couldn't discuss their projects with family or colleagues outside the program. Test flights were conducted at night to avoid detection by satellites or curious onlookers. The pilots who flew these prototypes risked their lives testing aircraft that were inherently unstable, unproven, and often experimental in both design and materials. 2. Hev Blue prototypes were destroyed during testing. But even those losses were buried under layers of secrecy. The development of stealth technology wasn't purely about innovation. It was also a reflection of strategic necessity. During the Cold War, the primary threat was radar-guided air defense systems capable of detecting and shooting down conventional aircraft long before they could reach their targets. To maintain a strategic edge, the United States needed aircraft that could penetrate deep into enemy territory undetected. This requirement drove the Pentagon to invest heavily in stealth research, even when early designs seemed impractical. The success of these unseen prototypes justified those investments. By the late 1980s, the operational deployment of the F-117 Nighthawk demonstrated that stealth could change the balance of power. During the Gulf War, F-117 struck heavily defended targets in Iraq with minimal losses, validating decades of secret research and billions of dollars in development costs. Stealth design during the Cold War also extended into reconnaissance. The SR-71 Blackbird, though not a stealth aircraft in the strictest sense, incorporated stealthy features such as radar-absorbing materials, angled edges, and special coatings that reduced its radar cross-section. Its speed and altitude further contributed to its survivability. It wasn't invisible, but it was nearly impossible to catch. The lessons learned from the SR-71 program and materials, high-speed flight, and radar signature management directly influenced subsequent stealth aircraft designs. Even the U-2 spy plane, another product of Lockheed's Skunk Works, underwent modifications to reduce its radar visibility after initial flights showed it was more detectable than expected. These refinements in reconnaissance aircraft stealth were crucial stepping stones to the development of later unmanned systems. By the late stages of the Cold War, the design philosophies of stealth aircraft had evolved from purely faceted designs like Have Blue to smoother, more aerodynamically efficient shapes like the B-2 Spirit. This shift reflected a growing understanding of how radar waves interacted with curved surfaces. The B-2's flying wing design was a masterclass in radar evasion, minimizing edges and corners that could produce radar reflections. It used advanced composite materials, carefully engineered skin panels, and meticulously controlled manufacturing tolerances to maintain its low radar signature. The B-2 was capable of carrying heavy payloads over intercontinental distances while remaining virtually invisible to radar, a feat made possible by decades of trial, error, and experimentation in the shadows. Each prototype from the Cold War era contributed something vital to the evolution of stealth technology. Some, like Have Blue, proved the concept could work. Others, like Tacit Blue, introduced new shaping philosophies. Projects like the Quiet Attack aircraft explored the boundaries of sound and heat suppression. Even those that never flew or reached full development status provided valuable data that would shape future designs. The combination of these experiments formed the DNA of modern stealth aviation. The lessons learned about radar scattering, thermal management, and structural integration continue to influence the design of current and future aircraft. What's equally fascinating is how many of these aircraft remained hidden from public knowledge for decades. The first hints of their existence often came from UFO sightings near test ranges or leaked photos, mistaken for extraterrestrial craft because of their bizarre shapes. It wasn't until long after the Cold War ended that governments began to acknowledge these programs. When declassification finally came, aviation historians were astonished by how far ahead engineers had been working, developing technologies that were decades ahead of their time. Even now, there are likely prototypes from that era still hidden under classified designations. There are details waiting to be revealed in the future. The stealth revolution that began in the Cold War fundamentally changed how wars are fought. Instead of brute force and overwhelming numbers, modern air dominance depends on information control, precision strikes, and invisibility. The unseen prototypes of that era were not just aircraft. They were embodiments of a new philosophy of warfare, one that valued deception, precision, and surprise over sheer power. From faceted diamond shapes to sleek flying wings, from radar-absorbing coatings to computer-controlled flight systems, each breakthrough represented a leap into the unknown, guided only by mathematics, engineering, and the determination to stay ahead of the enemy. The engineers and pilots who worked on these projects weren't just building planes. They were redefining the very concept of air combat. As we look back on the declassified Cold War stealth aircraft, it becomes clear that these prototypes were far more than experimental machines. They were secret ambassadors of a technological war fought in silence, in laboratories, and over the endless desert skies. Every unseen prototype, every classified test, every crash covered up with a fabricated story contributed to a greater whole, the birth of truth. And while the Cold War may have ended, the principles born from these projects continue to evolve, shaping the unseen aircraft that fly in today's skies and those still hidden in tomorrow's shadows.